All right, this is 1-7 on function notation. Some numbers can be described as an equation. When the set of ordered pairs described by an equation satisfies a function, then we use function notation. So the first example here says f of x equals 5x plus 3. The output value is the f of x, and the input value goes in for x. The second example is f of 1 equals, and what you do is you input 1 in for x. Caution, f of x is not f times x or f multiplied by x. It means the value of f at x. So f of 1 represents the value of f at x equals 1. So then we have some more notations here. The output of a function is called the dependent variable because it depends on what you sub in for the input. The input x is called the independent variable. When a function is graphed, the independent variable is graphed on the horizontal axis, so the x-axis, and the dependent variable is graphed on the vertical. So just go ahead and add the word x-axis and y-axis. So here's an example of a function. The independent variable is your x-axis, and that's your time. And then your vertical axis is your d of t. In this case, it would be the distance traveled. And this is the y-axis. Example 2, for the function, we want to evaluate it for 3 different inputs. So f of x equals 8 plus 4x. You input right in for this x, right in here. So we're going to input 0 into the function and then simplify using our orders of operation. So 8 plus 4, and I'll replace that x with 0 because this is our input. And then we simplify. 8 plus 0 equals 8. Next one, f of 1/2. So we input 1/2 in for x. Then we simplify. 4 times 1/2 is 2. 8 plus 2 is 10. Next one, f of -2. 8 plus 4. Replace that x with -2. So 8 plus -8 is 0. Now we have a graph of a function, and we want to evaluate the function. So the input represents the x. So f of 0, so here's our x-axis. And we're going to go to that x-axis at 0, so here's 0. And we go up and find that red curve. So this ordered pair right here is over 0, up 3. So f of 0, the output is our y value of 3. Now we're going to go to 1/2. So we go on our x-axis to 1/2. Here's 1/2. And there, find that red curve. So the ordered pair is over 1/2, up 0. So our output is our y, 0. F of -2. So here's -2 on the x-axis. We go up and find that curve, the red curve. What is that ordered pair? -2, 4. So the output is 4. Here's a diagram of discrete functions and continuous functions. Notice the difference. In a discrete function, there's no points connected and there's breaks, where a continuous function has no breaks. Now we're going to go ahead and graph a continuous function. So f of x equals 3x minus 1. So we're going to go ahead and just evaluate the function for 3 different inputs. You can choose any numbers that you want, but we're going to just choose nice small numbers around the origin. So we're going to evaluate the function first for negative 1. So 3, replace that x with negative 1. Then we do orders of operation. 3 times negative 1 is negative 3. Minus 1 is negative 4. So what we just found is an ordered pair on the function, on the curve. So negative 1, negative 4. So let's go ahead and graph that. So we're going to go left 1 and then down 4. All right, next one, evaluate it for 0. So 3, replace the x with 0. Simplify. 0 minus 1 is negative 1. So our next order pair is over 0, down 1. Evaluate it for 1. 3, replace the x with 1, minus 1. 3 minus 1 is 2. So the order pair is 1, 2. So now I go right 1 and up 2. Now we're going to go ahead and create our curve. So there is our nice straight line. The next example is a discrete function. So we are not going to connect the points. And this is a mapping diagram. So this mapping represents the ordered pair 3, 2. So we go right 3, up 2. This next one represents the ordered pair 5, 6. So we go right 5, up 6. Then we have 7, 10. So right 7, up 10. And then 9, 10. So there is our function. It does pass the vertical line test. This one up here passes the vertical line test. These are all functions.